Welcome to the second night of presentations. Tonight you will hear a wide range of topics related to GIS. My name is Brett Stauffer, and the title of my talk is The Distribution of Sahara Mustard on the Barium Goldwater Range. All right, so here's a brief roadmap of today's talk. I will start out by introducing Sahara mustard. I will then go into the study area and questions. I will then enter into my methods, results, and end with my conclusion, followed by a brief discussion. All right, so just a little bit about Sahara mustard. Sahara mustard, Brassica tournefortii, first appeared in the Coachella Valley of California in 1920. Scientists believe that it came from northern Africa or the Middle East through the importation of date palms. Since then, it has spread throughout the southwestern United States, adversely affecting deserts. And many scientists have shown that its spread is aided by roads because the seeds can attach themselves to car tires. And land managers have identified it as a species of concern for a number of reasons. First, it changes the fire regime in desert ecosystems, and it introduces fire into areas that didn't have it before, such as dunes. And it also, secondly, it outcompetes native vegetation for resources. So again, scientists have shown that brassica seeds can remain viable in the soil for up to three years, and then when it becomes favorable, they can sprout up and outcompete native vegetation and just flourish. And so as a result of all these bad things, land managers have identified brassica as a species in need to locate and eradicate. Okay. All right. So this shows this is kind of the place. So the Tinajas Altas desert region in southwestern Arizona. The main landowner is the military. The Marine Corps and the Air Force manage the 1.7 million acre Barium Goldwater Range, also known as BMGR. The National Park Service manages Oregon Pipe Cactus National Park, and you can see that kind of in the bottom here. And then the National Wildlife Service manages Cabeza Prieta National Wildlife Refuge right on the border there. And the study area for this project is actually the western part of Barium Goldwater Range, which is shown with the red polygon. Okay. So some of the questions of analysis. My first question, is there a relationship between the location of Sahara mustard, Brassica tournefortii releves, and vegetation communities? The second question, is there also a relationship with environmental and locational variables? And for your information, a releve is used in vegetation studies to sample a much larger landscape. And I also show a picture of creosote bush. If you've been in the desert, it is quite abundant, and it is shown all throughout Barium Goldwater Range, so that is definitely an abundant species. All right, so this map shows the study area in Barium Goldwater, which is Barium Goldwater West, and you can see that it is just to the east of Yuma, Arizona, and to the south of Interstate 8. Which runs to California. And this map also shows the 205 releves that Dr. Malusa, who I worked with, he sampled them from 2001 through 2013. And it also shows a random sample that I used within the logistic regression. So, okay, and next slide. The two analysis techniques that I used include include chi-squared analysis and logistic regression. Chi-squared analysis determines at a level of confidence whether the brassica relevae are randomly distributed across the study area. Logistic regression determines whether the presence or absence of these same brassica relevae are correlated to environmental variables or locational variables, such as aspect, slope, distance to sand, and many others. So a few steps that I use to calculate the chi-squared statistic. I use the identity tool to sample off a vegetation layer polygon that is currently being created by Dr. Malusa, and it samples a polygon. I use the identity tool to sample off a vegetation polygon that returns a code based on the dominant vegetation association within that polygon. I then use summary statistics to aggregate the total number of relevaes in each vegetation polygon, followed by also getting the total area for each vegetation association. A little bit complicated. And then in Excel, I calculated the expected value based off of the proportion of area for each vegetation association. And I used the following equation to calculate the chi-squared statistic, which is observed minus expected squared divided by the expected. And I wanted to discard polygons with no relevaes because it's not important to include those in the analysis. Okay, so this is the vegetation layer that Dr. Malusa is currently creating. And each polygon, 10, 17, 82, are coded based off the dominant vegetation association within that specific area. Okay, so if we look, we have vegetation polygon 17, which is triangle leaf burst age with less than 10% Palo Verde and ironwood. Okay, and we also have vegetation polygon number 10, which is creosote bush dominated. So you can see that the creosote and many other creosotes throughout the photo. Okay, so those are some of the polygons. Here are some of the steps for the logistic regression. I started out by preparing the variables, creating the rasters. I followed that by going into sampling of the variables using the sample tool in ArcMap. I then looked at the regression in SPSS, which is a statistical software. And then I created the model in ArcMap. And then I evaluated the model using this equation on the board, which gives you the efficiency, and it's the percent of total area most likely divided by the percentage of total sites. So some of the variables I included in the logistic regression included total relief, slope, precipitation from 2014 downloaded from Prism, distance to roads, distance to sand, distance to wash, elevation, and aspect. And I chose distance to roads and distance to sand because those studies have also shown that brassica likes to sprout next to roads and also likes sandy environments. So that's why I chose those two. Some of my results, the logistic regression returned significance for the following 4 variables. The first one is distance to roads, total relief, distance to wash, and elevation. And also include an DM for the study site. It's in meters. All right, so now the result, the 4 variables returned a probability surface that showed that correctly identified 77% of the releves with brassica, but it required over 40% of the land area in the study area. So as a result, it brought down efficiency. Okay. All right, chi-square results. All right, the next slide shows the chi-square results. I didn't include 62 releves because the vegetation polygon was not completed. I also did not include 5 releves because 2 of the habitats, 67 and 80, had a low sample size. So that returned an N of 138. And as a result, I had 4 statistically significant habitats. The first one is creosote and white bear sage with blue palo verde in a floodplain. The second one is creosote and big gleta grass. So that's this association. And then we have a dune environment with white bear sage, big gleta grass, and creosote bush. And finally, the fourth one is a white bear sage, creosote, and ironwood dominated environment in a foothills landscape. All right, so a few conclusions. Surveying and associated habitats will save time in finding brassica. And if I go back to the introduction, land managers want to find Sahara mustard faster and eradicate it. So as a result, these findings might help in terms of decreasing the amount of time in finding brassica and increased time for eradication. So a few kind of things to look at for further study. I would like to update the model with the vegetation layer once it is complete. I would also like to look at the creation of a disturbance raster. Again, I read some studies that showed that Sahara mustard likes disturbed areas. So it would be nice to quantify this in a raster from value 0 to 10, depending on the level of disturbance in that area. And some disturbances that you might want to look at include areas beside roads, illegal camps, off-road vehicle use, hiking, stuff like, and illegal camping. I would also like to look at climatic variables. Now, I included one February precipitation from February 2014 because the data from the PRISM was not very good for this area. So, and I also look at how brassica responds to seasonal fluctuations in monsoonal precipitation compared to native vegetation. Because in the Coachella Valley, they showed that brassica will come back faster than native vegetation and outcompete it. So it would be nice if that is done on the BMGR. So with that, I would like to thank all the MSGIST staff, our professors, Dr. Malusa for helping to provide the data and also the photos of barium Goldwater Range, and also helping on some of the analysis. And with that, I can take some questions.